Okay, now we are going to get started on hypothesis testing. As a first matter of business, I want to clarify the distinction between a confidence interval and a hypothesis test. Okay. A confidence interval creates a range of values. So a lower bound and an upper bound, right? Smaller number, bigger number creates a range of values, an interval likely to contain the mean at a predetermined level of confidence. So, in other words, we're creating two different numbers that we think the population mean will be found in between at a reasonable level of confidence. Okay. So, in other words, if we have a 95% confidence interval, we think that out of all the intervals we could ever create, 95% of the time, the mean will be inside our one interval, okay, inside the interval that we create right now. We're 95% confident of that occurring, even though the probability of that actually occurring is 1 or 0 for that one interval right there. Okay. So that's a confidence interval. The point of a confidence interval, like, why would I create a confidence interval? The point is to create a range of values, lower bound, upper bound, that will likely contain the mean, right? How long does it take to get to your friend's house? Oh, between 10 and 15 minutes, right? How long does it take for a flight to get to Los Angeles International Airport? Between 5 and 6 hours, right? How long does it take, or what will the stock price of IBM be at close today? Between $150 to $200. Okay. Those are ranges of values. That's a confidence interval. A hypothesis test, the whole point of a hypothesis test is to determine whether it is reasonable or unreasonable to believe some sort of suspicion or a hunch or a hypothesis. Okay. The way that science works, okay, and this is just true in general, this is the scientific method, is that human beings observe. We see the world and we start to say, okay, well, it seems like every time X happens, that leads to Y. And then we start to impute causal inference on things. We start to say, all right, I think X is what's causing Y. That's my hypothesis. And then what we do is, after we have a few observations, after we observe something, we start to see these relationships. We start to impute causal inference to it, causality. And then we say, I want to test it. I want to know if X leads to Y. So, in other words, you want to test your hypothesis. What you are doing with hypothesis testing is you are trying to determine whether it is reasonable or unreasonable to believe that a certain hypothesis, hunch, suspicion is true. Okay, so that's the whole point of hypothesis testing. Now, let's talk about one sample hypothesis testing versus two sample hypothesis testing. When it comes to one sample hypothesis tests, what we are doing is we are trying to determine whether or not it is reasonable to think a specific hunch exists, right? A hypothesis in relation to a specific value. Okay, so we're trying to figure out the relationship between our population and a specific value. Will the Mets win 100 games or more this season? Okay, how would that be relevant? Well, it's relevant for sports betting, right? That's a huge business now. For handicapping, it'd be relevant for concerts at the baseball game. And obviously, you have to have contracts as well in finance. So we want to know, will the Mets win 100 games or more? We want to know if Home Depot's stock price will be $60 or less. We want to know if the peso dollar exchange rate will be 19 pesos per dollar. Okay, these are all different types of exchange rates. Okay, exchange rate, all different types of hypothesis tests. Okay, in the first one, we want to know if the Mets are going to win 100 games or more. And the second one, we want to know if Home Depot stock price will be $60 or less. We want to know if the peso dollar exchange rate will be 19 pesos per dollar, if it will be equal to. Okay. But in all those different cases, we are trying to test the relationship between a population, right? The Mets, Home Depot stock price, peso dollar exchange rate. We're testing the relationship between those populations and a specific value. And a specific value. That is the point of a one sample hypothesis test. The point of that, in a one sample, we are looking at a hunch, a hypothesis, and its relationship to a specific value. Is it greater than that value? Is it less than that value? Is it equal to that value, right? That's what we're testing. Okay? That's the point of a one sample hypothesis test. A two sample hypothesis test no longer cares about the specific value. Okay? So, in other words, when it comes to a one sample, we care about, the population and a specific value. Will Jersey City's per capita income be $100,000 or more? Right? We want to know if the income in Jersey City is going to be 100 grand, $100,000 or more. So we're talking about the relationship between income in Jersey City and a value. That's a one sample hypothesis test. A two sample hypothesis test no longer focuses on the specific value within a hypothesis. A two sample hypothesis test only cares about comparing one population against another population. Okay, so in other words, keeping the Jersey City example, we might want to know, is the per capita income of Jersey City greater than or equal to the per capita income of Hoboken? Okay. So, in other words, we're not really caring about what the value is, right? The Jersey City income could be $10 and Hoboken's could be $8. Then we would say, oh, look, it's greater than. Okay. Or it could be $100,000 versus $80,000. And then we'd say, oh, okay, it's greater than, right? Or it could be, $1 million versus $800,000. We would still say, look, the Jersey City income is greater than Hoboken's. But with two sample hypothesis tests, we don't really care about the numbers so much as we care about the relationships between one population and another population. Okay. So just to real quick, if you were doing a two sample hypothesis test, you would be saying, all right, is the average unemployment rate of New Jersey lower than New York's? Right? Is the unemployment rate in New Jersey lower than the unemployment rate in New York? And then you would have your answer. You'd say, oh yeah, it's reasonable to think that. It's unreasonable. Okay. The one sample hypothesis test is you would say, all right, well, is the unemployment rate in New Jersey 5% or less? Okay. So again, the numerical values come in with the one sample hypothesis test. You're testing a population against a number. For a two sample hypothesis test, you're testing your population against another population. Okay. Some of the things that we always say, like colloquially in, just like in everyday common talk, usually that's basically like a two sample hypothesis test. You say, oh, the Yankees are better than the Mets, right? How do you know that, right? Well, you're comparing one population against another. How should you get to Philadelphia from Jersey City, right? Oh, well, should you take the Turnpike or should you take the Parkway to 195? And, that's probably out of the way. But should you go that way? Oh, okay. Well, that's comparing two populations. You don't care if it's going to take you 30 minutes or 3 hours on the Turnpike to get to Philadelphia, as long as it's less than or equal to the Parkway, right? So the one sample would be, to go from Jersey City to Philadelphia, will it take me 2 hours or less? That's a one sample because we're comparing it to a specific value. But the two sample would say, okay, what's better to get to Philadelphia, the Turnpike or the Parkway? Okay. And then finally, just to tie it all back around, a confidence interval would tell you, okay, it's going to take you between 1.5 hours and 2.5 hours to get to Philadelphia. Okay. So you see, these are all interrelated tools of a quantitative analysis, but they're all very different. Okay. Confidence intervals create a range of values likely to contain the mean. A hypothesis test is trying to figure out whether it's reasonable to believe a hypothesis, a hunch, a suspicion, and its relationship to a specific value. And then a two sample hypothesis test is trying to figure out what is the relationship between this population and a different population. Okay. So just keeping that example of driving from, Jersey City, from St. Peter's to Jersey City, from Jersey City to Philadelphia, you could see that Waze, Google Maps, whatever your GPS navigation system is, right? All of those, they all use one sample hypothesis tests, two sample hypothesis tests, and confidence intervals all the time. When you program in an address and they tell you, all right, we think it's going to take you about this long between this and this, right? It's going to take you between an hour and a half and 2.5 hours. That's a confidence interval. Then they tell you, all right, to go from here to there, it takes 2 hours. That's a hypothesis test. They're saying, all right, we believe it's reasonable to think that to go from here to there is exactly 2.5 hours. Okay. But we're confident it's going to take, between an hour and a half and 2.5 hours. And then it would also say, by the way, you could also take this other route, right? You could take a different road, different road system, different road connections, but that's going to take you longer. So, in other words, we are sure that going this route that we're suggesting is much faster than going this other route. Okay. So, what I just did there is I tried to tie together for you confidence intervals, hypothesis test, one sample hypothesis tests, and two sample hypothesis tests. Okay. That's the distinction between all of them. Finally, before we get going into hypothesis testing, right, our foray into one sample hypothesis tests, I just want to point out something very important, very basic, but very important. In hypothesis testing, we are going to ask ourselves many of the same questions that we asked ourselves with confidence intervals. Okay, for example, we are going to ask ourselves, do I know the population standard deviation? We're going to ask ourselves, what are the degrees of freedom? Okay, we're going to ask those questions. But I want you to understand that just because we are asking ourselves the same questions in confidence intervals and in hypothesis testing does not mean that they are related at all. Okay. Technically, they are related, but we don't need to get into sort of that stuff now. That's for different levels. Okay. That's for more advanced stuff. For now, you just have to understand just because we're asking ourselves the same questions in confidence intervals and in hypothesis testing does not mean that the two are related. Okay. Think about it like this. When you're playing hockey, ice hockey, your team probably asks yourself, you probably ask yourself, is my team winning? When you're playing basketball, you probably ask yourself, is my team winning? Same question, two completely different sports. Nobody's ever going to confuse basketball and ice hockey, right? One's played on hardwood, the other's played on frozen water. Okay. Two different sports, totally unrelated. Same question. Am I winning? Right? Well, Just think about that, like when it comes to confidence intervals versus hypothesis tests, right? Do I know the population standard deviation? What is the degrees of freedom? Is this a sample or a population, right? Just because we're asking ourselves those same questions in hypothesis tests and in confidence intervals, just because we're asking ourselves that doesn't mean that they are related at all. Okay. Don't think about that. Okay. So you are going to be hearing a lot of the same questions, but they're two totally different statistical tests. Okay. These quantitative methods are completely different. Okay. So with that, I've said the introduction to hypothesis testing, right? One sample, two sample confidence intervals. And in the next lesson, we're going to start in on the steps, the 5 steps of any hypothesis test.